Okay, so we have a word problem. We love word problems. Remember, the way that I do word problems is I read the problem and then I work backwards through the problem, see if there's a formula that I have, but work backwards to say what I'm going to get for an equation and then try to figure out what goes into the equation. So in a lab, Charmaine has two solutions that contain alcohol and is mixing them with each other. Solution A is 60% alcohol and solution B is 10% alcohol. She uses 300 milliliters of solution A. How many milliliters of solution B does she use if the resulting mixture is a 40% alcohol solution? All right, so it's a percent problem, so we do need to know that percents, the general formula for percent is percent of a whole is your part. Of is times, so we always have the total amount that we're using, and then we're going from there. So we want the resulting mixture is 40% alcohol. So results, mixture, equals, it's part A plus part B. Because that's what we're putting together into that big box or beaker that we're mixing the stuff. Now, the resulting mixture, I need 40% alcohol. And I'm thinking, okay, so I need 40%. And I need that to be the whole. So how much of A and B were we putting in there? So this is going to be A plus B. But we need to think about this. So going back, we are going to be, I'm probably going to come back to that. How many milliliters of solution B does she use? We don't know. So B is going to be our X, probably. She uses 300 milliliters of solution A. So if I'm looking at A, I'm going to change color just because this is getting too confusing. So if I have A, that's not much of a color difference. So let's change it a little bit more. Okay. So A is the percent, which we know is 60%. So I don't like using the percent symbol. So this is 0.60 or 0.6. Of is times. The whole part, they told me I'm using 300 milliliters equals part A. But I know that I used 300 milliliters of A. So when I'm doing my mixture, the A is the total. So this is 4.4, 4.40. This is 300 plus, when I'm looking at B, I don't know how much I'm going to use. This decimal is kind of disappeared. But I know my percent is 10%, so 0.0. And I don't know what my B, and that is going to be my part B. So I'm going to call this X for my part. Now I'm going to be putting in to what parts I know. So I know 0.6 times 300. This is the same thing as 0.6 times 300. Now I'm multiplying things together, so I could move one decimal here, get rid of 1 0 here because it's counterbalancing each other. So this is 6 times 30. 6 times 3 is 18, and add the 0. So part A is going to be 180 plus, I don't know my B, but it's going to be this 0.1. I'm going to get rid of that 0 because it's just going to throw things off. 10x. Now this is what I have to solve. I'm going to get rid of this 0 because it's just a placeholder. It's after the decimal, so it's just making things more confusing. This is the same thing as 4 times 30 plus 0.4x equals 180x. 180 plus 0.1x. All right, so I have 4 times 30 is 4 times 3 is 12. with S0. All right, I want to get the x's together. I always move the one with the smaller coefficient first. So we are going to subtract the 0.1. All right, so we have 0.3x. And then on the same side with that, I do want to get rid of anything that is added or subtracted. So I'm going to subtract the 120. 120. So that will equal 60. I'm going to divide by 3, the 0.3. All right, and then when I have this, that will give me, this color, this will cancel out. Now, I don't like the decimals and fractions. We can't have them. We have to do, since one is on top, one is on the bottom, we have to do the exact same thing, top and bottom. So this is the same thing as 3 going into 600. So this is x equals 200, which seems reasonable. We're going to end up with 500 milliliters of a solution. That should be for 40%. So we'll put our 200 in there, and we should be good on this. It's a little bit of thinking, a little bit of remembering what definition means of a percent, and then just plugging stuff in once you write what they're asking for, that equation. Okay, and they should have said milliliters, but we're good with that.